Alright, what's up guys? So in this video I'm going through all 17 problems on your review sheet for the rational unit. I'm just going to go through and explain the process, what you should be thinking about, the final answers, just following all the directions, and if you can do these 17 problems, you'll be fine on the test. Okay? So any other questions you have aside from this video, please contact me and we'll figure it out together. Okay, so going through number one, it's a bunch of different factors, numbers, x, y, z, all these variables. There's no plus or minus here, so we just take out whole letters or whole numbers. Okay, this is like the first problem on your quiz. All right, so this is what we're gonna do. Let's start with just simplifying each piece. I like start with the numbers. Like I see like -3 and 12 can go to like about -1 and 4. Okay, and how about 4 over 10 can reduce to 2 and 5, something like that. Okay, so those are how the numbers reduce down. I see that we have 4 x's and 7 x's on the bottom, so that's going to go to x cubed. Okay, and how about these y on bottom and the y squared on top goes to y. I got 2 z's on top and 6 z's on bottom, so going to go z to the 4th. And it's getting a little jumbled, so let's go ahead and multiply everything out and see what we got. Looks like we got 2 times y times 4 on top, okay, which will be 8y. And on bottom we have -1 times 5 is -5. Looks like x to the 3rd and z to the 4th. I don't see anything else that can simplify out in this problem. Okay, the y's, the x's, the z's, the numbers can't reduce down, so we're done. That's the answer. As far as the restrictions go, it's just whatever x, y, and z cannot equal. And since there's no plus or minus in those factors, all three of them cannot equal 0. Alright? And if any time you think I'm going too fast, just remember this is a video. Go back, rewind it, pause it, do what you need to, but I'm just going to go through and just continuously go through these problems. So, here we go. Alright, number 2. So again, we're factoring it. It's just one fraction, so all I got to do is factor the top and factor the bottom. Okay, so the top here seems to factor to x minus 3 and x minus 2. It's the factors of +6, that is -5. And on bottom, I'm not sure why I drew 2 parentheses just yet, because you can take out a GCF of 4, and you're left with x squared minus 4. And then that's the difference of squares that we can factor to x minus 2, x plus 2. Okay? So I have x minus 3 times x minus 2 over 4 times x minus 2 times x plus 2. Once you're factored, I think this is a good step to maybe go ahead and label the restrictions. So like, what can x not equal? Well, in this case, it's the numbers that make the bottom 0, and that's 2 and -2. Okay? Alright, so how does this problem simplify? Well, we have an x minus 2 on bottom and an x minus 2 on top. So that reduces to x minus 3 on top divided by 4 times x plus 2 on bottom. There we go. On number 3, we got 2 fractions dividing by each other. Okay, so remember what happens with that. The first thing I would always do is just remember to change that to a multiplying and go ahead and flip your top and bottom. So like x squared plus 2x plus 1 goes on top and 2x goes on bottom. Alright, so now this is just a multiplication problem. All we gotta do is factor all the pieces and reduce them. Okay? So the top looks like factors to with the GCF of 2x coming out. So I got 2x times x minus 1, it looks like. On bottom, I got the factors of this, factors of 4 that add up to 5. That's x plus 1, x plus 4. And this multiplies to, okay, well the top right factors to, it looks like x plus 1 and x plus 1. And the bottom factors to 2x. Okay. Now, before we go on, let's go ahead and say what x cannot equal. Alright, well in this problem, x cannot equal the things that make the bottom left, the top right, and the bottom right. What makes those zeros? Don't forget to include the top right portion, because at one point that was on the bottom before we flipped. So what cannot make this cannot work in this problem that makes the bottom 0 is -1. Just going from left to right here. -1, -4. All right, with this 2x factor here, 0 cannot make that work. And then at the top is -1, but we already got that accounted for. Okay, so that's what x cannot equal. Now, just see we can cross out diagonally or up and down. So it looks like we have an x plus 1 crosses out with an x plus 1 here. Looks like I have a whole 2x and a 2x here that crosses out. So then it looks like what I'm left with is x minus 1 times x plus 1, and on bottom, x plus 4. And that is my answer. All right, moving on to number 4. We're adding now. Okay, so when I add, I got to get a common denominator. Okay, so let's figure out what the lowest common denominator is in this problem. All right, what we need to multiply the left and right side by. Okay, well, it looks like this right here. So what they share in common is this has a y and this has one y. Okay, so like the only thing they have in common is one y. So what the left side is missing is the 4 and the x. All right, 4 and the x. Oh, and an additional y. Okay, so now it has the 4, it has the x, it has the additional y. Well, what the right side is missing is just the 3. Okay. Now, if I were to multiply that out, that's 3 times 4. The lowest common denominator is 12, 1x, and 2 y's. Okay, so 12x y squared. And the numbers we got to multiply here in red, we got to multiply on top and bottom, and now they have the same denominator. So I'm going to go ahead and write the same denominator because both the denominators multiply to 12x y squared. And on top, if I were to multiply this times this and this times this, I have 20x squared y plus 12. And can we reduce that? Well, looks like between all three numbers we have maybe a factor of, let's see, maybe 4 can divide out all those. So like I could take out a GCF of 4, and I'm left with 5x squared y plus 3 over 12x y squared. Well, the 4 and the 12 reduce down. So my final answer is 5x squared y plus 3 over x y squared. And remember, because this x squared and y on top is married to this 3 with the plus, you cannot divide it out from the bottom. Okay, they all have to have it in common for that to work. So there's my answer. As far as the restrictions go, it's what x and y cannot equal. In this case, x and y both cannot equal 0 because there's no plus or minus with them on the bottom. So it's just 0. Number 5 is the same as number 4, but now we're talking about minus. So again, you want to figure out what they have in common on the bottom and what each side needs. So I think the best thing to start is to factor top and bottom. Factor top and bottom. So okay, it looks like that the factor they have in common is x plus 2. So this side already has the x plus 2 on the right, but it needs x minus 2. And now they have a common denominator. They both have x minus 2 and x plus 2. The left side doesn't need anything to have all of the factors. I guess now's a good time to go ahead and maybe tell us what the restrictions are. Like x cannot equal what makes the bottom 0, and again that's 2, negative 2. Alright, so how it works is we got the common denominator of x minus 2 and x plus 2 on the bottom. And on top I have 3x still, and now it's minus 6 times x minus 2. I mean, I like it to this point. People get this point all the time. Please don't make the mistake of trying to cross out x minus 2 on top and bottom. You have to factor the top first. You have to distribute everything. So, like, that's going to be 3x minus 6x minus 12 all over x minus 2, x plus 2. And keep simplifying. Looks like the top's going to reduce to a, looks like 3x minus 6x is negative 3x minus 12, all over x minus 2, x plus 2. And that looks to be the answer. I mean, I guess on top you could take out a negative 3, but that doesn't really help us at all because it doesn't reduce anything on the top or bottom. So there's really no point to get to this point, but either one's good with me. All right, number 6. So we got 2x over x squared plus 2x minus 3 minus 5 is the same thing as number 5, but well, let's just do it. Okay. So again, we're adding or subtracting. We get the common denominator by seeing what factors they have in common. So x squared plus 2x minus 3, that factors to x plus 3 and x minus 1. Factors to negative 3, that adds 2. Well, it looks like the fact that they have in common is the x plus 3. So what's missing is the x minus 1 on this side. Okay. So now they both have the common denominator, and we just simplify the tops to see what happens. Before we do, let's go ahead and note what x cannot equal. And in this case, it's what makes the bottom 0, and that's 1 and 3. All right, so when I combine them together, on bottom I have the common denominator, x plus 3, x minus 1. And on top I have, let's see, 2x, and then minus 5 times x minus 1. Okay. Well, let's go through and reduce down the top before we can simplify. Okay? So I have 2x minus 5x plus negative 5 times negative 1 is positive 5. And then all over x plus 3, x minus 1. Okay? Well, reducing the top, I get negative 3x plus 5 over x plus 3, x minus 1. And I believe that is the answer because nothing else factors out and we're all set. Alright, so this verse 6 we were simplifying. Now we're actually going to solve for the value of x. Okay, now when solving with these, you got to get rid of the rationals. By doing that, you multiply both sides by your common denominator. Okay, so again, it's just like adding and subtracting. So let's figure out what each of these factor to. So this goes to x minus 1, x plus 1. Now if you notice, okay, so what they share in common is the x plus 1, the x plus 1. And what this side, and what they need, I guess, all right, is the 3, the x minus 1, and then the shared x plus 1. So my lowest common denominator in these problems is 3, x plus 1, and x minus 1. That's everything they share and everything they need. Okay. So let's remember, it's that value that we multiply the left and right sides by. Okay. So I'm going to multiply top and bottom over here by, I'm sorry, just the top over here by 3 times x plus 1, x minus 1. And I'll multiply this side by 3 times x plus 1 and x minus 1. All right, both of which are over 1. Now remember, when I do that, it's going to reduce down the common denominator, and I'll be left with an equation that's not a fraction. Okay? So like on the left side, the 3 and the x plus 1 cancel out. So I'm left with 4 times x minus 1. The 4 times the x minus 1. And on the right side, the x plus 1s cancel out, the x minus 1s cancel out, and I'm left with 3 times 12, which is 36. Okay? And now it becomes an equation that's really easy to solve. Just distribute and combine like terms. So 4x equals 40, and x equals 10. Yay! Let's try number 8. Number 8. All right. So between 2, 6, and x, what is my lowest common denominator? Well, between the numbers 2 and 6, the lowest common multiple between them is 6, and between the variables, it's an x. Okay, so LCD is 6x. So we multiply the left side by 6x and the right side by 6x. And you'll notice that the denominators reduce out and cancel out. Okay? Let's multiply them through. 6x times 1/2 is just, well, 3x. And then 6x times x over 6 would be 6x squared over 6, or just x squared. Okay. And then on the right side, the x's cancel out, and I'm left with 18 times 6. So we got rid of the rational, Now we're left with, I'm going to put this in order as x squared plus 3x equals, and 18 times 6 is 108. So if you notice it's a quadratic trinomial, we're going to have to get them all by themselves, so are equal to 0. And we're going to factor it. So you're going to sit here and think about what are the factors of negative 108 that add up to positive 3. Well, I'll give you a second to think about it. I need to think about it too. I'm going to think, I think it would be 12 and 9. So that would be x plus 12 and x minus 9, I believe. Yeah. That multiplies the negative 108 and adds the positive 3. So in this case, x equals negative 12 and 9. All right, let's try number 9 here. So again, you want to figure out we got to multiply left and right by to get rid of the fractions. So I got x plus 3 and x, and this is x times x plus 3. So it looks like that x plus 3 is my lowest common denominator. That includes every single one of my denominators. So my LCD is x times x plus 3. That's what I'm going to multiply everything by. Okay, so I'm going to multiply this by x times x plus 3, and this by x times x plus 3. Alright, when I distribute that through, let's see what cancels out. For the first fraction, the x plus 3's cancel out, so I'm left with 2 times x. And then minus, okay, so then the x's cancel out in the next fraction, so I'm left with just 1 times x plus 3. And it equals, on the right side, everything cancels out, the whole denominator, so I'm just left with the numerator, negative 6. So let's go ahead and FOIL the negative, see what we get. X minus 3 equals negative 6, x equals negative 3. So when we solve this equation here, we get x equals negative 3. Now, when we get down to x equals negative 3 as our answer, but do we see an issue with that? Well, if you look in our original problem, x plus 3 is a denominator. So that means if I plug negative 3 into that denominator, I get undefined. So I may have got a solution of x equals negative 3, but it's an extraneous solution, meaning that it's one of my restrictions. So this is the answer I get. It does not work. Therefore, this answer would be no solution. So be careful and make sure that every solution you get, it works in the original problem. All right, number 10. Number 10 is a complex fraction, solved very similar to the last few problems we just did. Y'all do pretty good with this. By simplifying these, all you have to do is get rid of the little mini fractions, and how you do that is you multiply by the lowest common denominator again, which in this case, between x and 3x, all right, the lowest common denominator is 3x. So my LCD is equal to 3x, and you want to multiply the top of the fraction by 3x and the bottom of the fraction by 3x. And remember, when you're doing that, you're multiplying or distributing it through the tops of the fractions, so all the tops of these little mini fractions. So I'm going to write this one out just so you can see it. That's like 5 over x times 3x over 1. And that's plus 6 over 1 times 3x over 1. That's what happens when I'm distributing on the top. On the bottom, when I distribute, I got 3 times 3x, which is 9x over 1, plus, and then I multiply the top, that's going to be 2 over 3x times 3x over 1. Okay? So all I did was just distribute that, and I like to be able to see that step, because now you can see what crosses out. All the little mini fractions go away. Like here, the x and the x go away. So it's going to equal just 5 times 3, which is 15. I'm going to switch colors. So those crossed out, 15. And then it's going to be plus, well, 1 over 1 just is nothing. I mean, it's just a whole number, so it's just 6 times 3x, which is 18x. And then on bottom, we have 9x over 1 is 9x. And then the 3x and 3x cancels out, and I'm left with just 2. And it doesn't look like anything can factor more from there or simplify more from there, so that will be my answer.
far as restrictions go, what x cannot equal in these problems is just what the little mini fractions cannot equal. And in this case, it's just 0. X cannot equal 0.
I don't want you to worry about finding the restrictions for complex fractions.
But just know it's just what makes the little mini parts 0. All right, start at number 11. So number 11, our factors on bottom are x minus 2. We got a x here. We got a x minus 2 and an x plus 2. Okay, so I'm going to rewrite this as 3 over x minus 2 plus 3 over 4 over x minus 2, x plus 2, and then plus 1 over x. Okay, so I just rewrote it with it factored out.
Now, between all of your denominators, the ones they have in common is,
So if your lowest common denominator is equivalent to x minus 2, x plus 2, and then we also have an x. Okay? So that's what I'm going to multiply the tops and bottoms of this big old fraction. So x minus 2, x plus 2, and x, right, and x minus 2, x plus 2, and x. Alright, so I'm not going to write out the whole thing this time. So just know that I'm going to distribute this to the tops of all of these fractions. Okay? When I do it to the top left one, the x minus 2 cancels out, and I'm left with 3x and x plus 2. The 3 has nothing with it, so that's just going to itself be plus 3 times, I'm going to say 3x. And I still have the x minus 2 and the x plus 2. None of those canceled out. On bottom, both the x minus 2 and the x plus 2 cancels out, and I'm left with just 4 times x. And then on the right fraction, the x is canceled out, so I'm left with just x minus 2 and x plus 2. Okay. Now, before I start trying to get too crazy with simplifying this, you have to factor and FOIL everything out because there's a lot of plus signs here. You got to combine all your like terms. So on top, you got to distribute, FOIL. I don't think anything is going to simplify down too crazy in this problem, but it doesn't hurt to check. So that's going to be 3x squared plus 6x in the top left, plus, all right, what's going on here is, well, x minus 2, x plus 2, if you were to FOIL that, that's the same thing as x squared minus 4. And then if I distribute 3x through to that, that's going to be 3x cubed minus 12x. And on bottom it's going to be 4x plus, and again, x squared minus 4. I don't think any of that's going to simplify out, but I guess it wouldn't hurt to write it in the correct order. So maybe like in descending power, 3x cubed plus 3x squared, and then minus 6x, if I combine like terms, and then all over x squared plus 4x minus 4. And that's the answer I'm getting. It might simplify further than that. Let's see if it does. If you got it there, I'm happy. But I'm kind of curious. It looks like on top you can actually take out a 3 and an x. I'm left with x squared plus x minus 2. And on the bottom it looks like you can factor 2 x. Can you factor that any further than that? Factors of negative 4, that up to positive. Yeah, that, well, actually I don't believe that works. I don't think there are any factors of negative 4 that add up to positive 4. Negative 2 and negative 2 usually negative 4. No, I don't think you can factor that any further. So I think you're just going to be left with that as your final answer. Nice. Alright, so number 12. Y'all like number 12. Y'all do good with these types of problems. All it is a work problem. Remember how this works. So suppose Bob takes 6 hours to do the yard work. If Jake helps him, it only takes 4 hours. How long would it take Jake to do the yard work by himself? Remember the formula for this. It's 1 over the time it takes one person, Bob, plus 1 over it takes the time for the other person to do it, in this case Jake, which I don't know, is going to equal 1 over the time it takes for them both to do it, in this case 4 hours. right? And then it's just an equation that you need to solve, which I would recommend by multiplying by your LCD to get it not to be irrational. In this case, I think the lowest common factor would be, I believe it's actually 12x. Because if I multiply everything by 12x, that should be the lowest multiple. Let's see. If I distribute the value, 12x over 6 reduces down to 2x, plus 12x over x reduces down to 12, and 12x over 4x on the right side reduces down to 3x. So it looks like in this case, if I were to solve this, 12 equals x. So it takes Jake 12 hours to do it by himself, which is more than the time it takes them to do it both together. That makes sense to me. All right, now we get down to the final bit, the graphing part. So you need to identify your horizontal asymptotes, vertical asymptotes, holes, okay? So I always start with my horizontal asymptotes, okay? And how I do that is I just compare the highest power on top, the highest power on bottom. In this case, we got an x to the first over x squared. The highest power is on bottom. Therefore, always your horizontal asymptote is y equals 0. All right, and then vertical asymptotes and holes are done at the same time. So how that works is you want to factor everything and see what crosses out. So here the factors of -6 add up to 1. That's +3 and -2. So what happens is this reduces down. The x minus 2's cancel out, and I'm left with 1 over x plus 3. As far as vertical asymptotes goes, it's what makes the denominator 0 after we've simplified it out. In this case, we're looking at the factor x plus 3. So -3 makes that 0, so that is my vertical asymptote. And remember, my holes is what makes the bottom 0 that does cancel out. In this case, that value is at x equals 2. Well, if I want the coordinate point, I got the x value. The y value is when I plug it into this equation here. All right, so that's 1 over 2 plus 3. And that gives me 1 over 6. Sorry, and add 1 over 5. Let's try the next one. So for the next one, again, I want to start off by talking about my horizontal asymptotes. Okay? You're comparing the highest power on top to the highest power on bottom. We got a 3 over 1 power. So the highest power is on top, and if that's the case, always it means that there are no horizontal asymptotes. All right, now vertical asymptotes and holes. Okay, so this all goes with what factors out, cancels out, and what doesn't. So let's see how the top factors. Looks like I can take an x out, and I'm left with x squared minus 3x minus 40. And does that factor more? Well, are there factors of -40 that happens to -3? In this case, that would be, so I got x. How about x plus 8 and x minus 5? So 8 times -5 is -40, and they add to -3. Or, actually, I apologize, it's the other way around. It's going to be -8 and plus 5. But regardless, everything on top does not simplify with anything on bottom. If nothing simplifies out, that means that as far as holes are concerned, we have nothing. And as far as vertical asymptotes goes, it's just what makes the bottom 0 that doesn't cross out. In this case, it's x equals -1. And I'm looking at that factor. All right, and then finally, let's do 15. Again, start with horizontal asymptotes, and you want to look at the highest power on top and bottom. In this case, they're both 1s. If that's the case, then all you do is take the leading coefficients in front of those variables. In this case, it's y equals 4 over -1, or just -4. All right. Now, as far as vertical asymptotes go and holes go, is there anything? Well, the top and bottom doesn't factor, so there is no holes because nothing cancels out with anything on top and bottom, so that's good. But as far as vertical asymptotes go, well, it's just what makes the bottom 0. In this case, -x plus 1 set equal to 0. Well, I can subtract 1 to both sides. I get that that negative x equals negative 1, and therefore x equals 1. So horizontal asymptotes compare the powers on top and bottom. Vertical asymptotes figure out what makes the bottom 0 after everything's canceled out, and holes are what makes the bottom zeros that do the cancel. Okay, so we're going to use all three of these pieces, these knowledge, whatever, to help us graph 16 and 17. 16 first. With these, I think it's helpful to find your horizontal asymptotes. I want us to find our vertical asymptotes, and then our holes. Those are really the only things I need to see. And you also have your calculator to guide you in the correct sketch. Okay. So let's start with horizontal asymptote. Well, the highest power on top is x squared. The highest power on the bottom is x squared. So they're the same. So you take the leading coefficients, which is just y equals 1. All right, as far as vertical asymptotes go, well, and holes, let's see how this bad boy factors. So that's going to be x minus 2 and x plus 2 on bottom. On top, it factors to x, I believe it's minus 3 and x minus 2, because those are the factors of 6, that's negative 5. All right, what crosses out? Well, x minus 2 and x minus 2 does. So I'm left with x minus 3 over x plus 2. Okay, so the vertical asymptote is what makes the bottom 0 that does not cancel out, which is the plus 2. So that means x equals negative 2 in this case. As far as the holes go, what crossed out that makes the bottom 0? Well, that's the x minus 2, so my hole is at x equals 2. Well, if I want that coordinate point, remember, you plug it into the simplified version. So you're going to do 2 minus 3 over 2 plus 2, which looks to be negative 1, negative 1 over 4. So negative 1, 4. All right, with these points, we're going to graph this bad boy. So vertical asymptote, we have it at negative 2, and holes, we have it at positive 2. I'm sorry, did I completely butcher that? No. My vertical asymptote is at negative 2, but my horizontal asymptote is at 1. I apologize. I was the wrong one. But my hole is at over 2 down negative 1/4. It's somewhere right here. Now, you can plug this equation into your calculator and see how the sketch works, but just judging based off where the hole is located, I got a pretty decent idea of how it works. But I think graphing it is also a good indication of what the rough sketch should look like. So that's what I'm doing right this second. And just to confirm, and yeah, that's what I figured. So it's going to look like this, and it's going to be flipped across the vertical asymptote, and it's going to go right through our hole. Looks like that. Pretty solid. So all I need is a rough sketch. I need to see the vertical asymptote and the horizontal asymptote for the hole. If I see these three things, then I'm doing all right. All right, and finally, last one, go through the whole process again. We're going to identify our horizontal asymptotes, vertical asymptotes, and our holes. Okay. Start with horizontal asymptote. We got the highest power on top and bottom is the same, so we take the leading coefficients. It's just y equals 2 over 1 or 2. Okay? Now I'll go ahead and graph it. Here is my horizontal asymptote at 2. Now, to figure out the vertical asymptotes and the holes, we are going to factor the top and the bottom. So the bottom factors to x minus 1, x plus 1. And doing bottoms up, I'll let you kind of go through the process of doing bottoms up. But when you do, what this factors to, whenever you factor that, it gets to x plus 1 times 2x plus 5. Now, what crosses out is the x plus 1 and the x plus 1. Okay? So that means that we do have a hole, and the hole is at what crossed out, which is x equals negative 1. So to figure out where that hole is located, right, so negative 1, you're going to plug that into the simplified version, which is 2x plus 5 over x minus 1. So that's going to be 2 times negative 1 plus 5 over negative 1 minus 1. Okay, which ends up being what? Negative 2 plus 5 is 3 over negative 2. So negative 3 times. And the vertical asymptote is what makes the bottom 0 that did not cancel out, and that's this factor here, which is x equals. Alright, so I graph the horizontal asymptote, the vertical asymptote is at 1. The the holes is at -1, so over here, and then -3/2, somewhere like right here. Okay, so the hole kind of gives me an idea of what this is going to look like. Again, I would graph that just to kind of verify what it's going to look like. I'm doing that now. So I'm getting what it looks like. So it is going to go through the hole, and it's going to be bounded by the asymptotes, and this one's going to do the same thing. Okay, as far as your test goes, these are the exact kind of problems you're going to see, these two types of graphs. Okay, your test is just like this review sheet, every single problem on here. Alright, so if you know how to do these problems, hopefully this video helped. Go back, watch it wherever you need to, pause it where you need to, try the problems on your own, see what you can do, and good luck. Look at my smiley.